Hey, algebra friends, here we are in chapter 4, and what we're looking at is section 4.7, arithmetic sequences. And this is a little bit of a weird topic to pick up right now, but it kind of relates to some of the function stuff that we're talking about. And your text and the authors of the text will kind of tie it in together. Don't feel bad if you don't see the exact tie-in. It's going to be all good. A sequence is basically just a list of numbers that are kind of in some kind of pattern or order. So for instance, this is a sequence of numbers 2, 4, 6, 8, 10, or here's another sequence of numbers. And if you were to take your time and look, you could probably come up with your own or try to think about, I don't know, maybe a way to, maybe a way to complete some of these sequences that I have here. So all of these are sequences of numbers. I didn't put a number here, let's say 12. So each of these represents a sequence of numbers, a list of numbers in some sort of a pattern. And there should be a way to generate the next number in the sequence, all right? So it's not just a bunch of random numbers. All right, so we've got these sequences, and sequences usually start off with a number and they have terms. So for instance, this sequence here might be referred to as this is the first term of the sequence, the second term, the third term, the fourth term, and the fifth term. So the word terms refers to each number, and we would usually put a prefix of first, second, third, depending on the numbers in the sequence and their location. Does that make sense? So if we were talking about the third term of this sequence, it would be -9. Or the fourth term of this sequence would be 1/8. So terms refer to the values in the sequence. An arithmetic sequence is a sequence that is created by adding a number to the last number. So if you would look here, two of these sequences are arithmetic sequences. This sequence is not an arithmetic sequence. If I were to think about where do I go from this number to this number, to go from 1/3 to 1/9, first of all, I'm going down, but that's not a consistent jump as I go from each term. But if you look from here, this term to this term, I jump to this term to this term, 2, 2, and 2. Got it. This term to this term. Now, I know it doesn't seem like I'm going up because I'm going from -3 to -6, but I am jumping -3. And so this movement of -3 lets me know that I have an arithmetic sequence. So an arithmetic sequence is generated by adding or subtracting a number from term to term. All right, so I'm going to say that an arithmetic sequence, basically it's a sequence where each term of an arithmetic sequence is generated by adding a number to the last term. All right, and the common difference is the amount that we add. So the common difference in this sequence would be 2. The common difference in this sequence is the -3. So the common difference is basically the difference between two consecutive terms in an arithmetic sequence. All right, so the common difference, as I said here, was -3. This doesn't have a common difference, and this is a different type of sequence, actually called a geometric sequence, but we'll talk about that at a later time. So identifying arithmetic sequences. Determine whether the sequence is arithmetic, and we're going to justify our answer. Let me make this a little bit smaller. We'll justify our answer. And so we know that an arithmetic sequence goes up by the same amount each time. So from here, from 1 to 2, from these two terms, I see a change of 1, and from here I see a change of 2, and from here I see a change of 4. So clearly this is not an arithmetic sequence. This is not an arithmetic sequence. There is no common difference. Let's check this one out over here. So if I move from 1/2 to 1/4, I'm dropping down a fourth, right? So from 1/2 to 1/4, if I were to take 1/2 and I were to figure out what I need to add from 1/2 to go to 1/4, I'd add a -1/4. Same thing here from 1/4 to 0, I'm dropping down a fourth. And then from 0 to -1/4, I'm dropping down a fourth. And so with that in mind, I can confidently say that this is an arithmetic sequence. Yeah, this is an arithmetic sequence because it does have a common difference. So this section where we're looking at this key concept is really to think about the terms. So when we deal with the terms of an arithmetic sequence, we would call the first term A1, the next one A2, the next one A3, just to think generically about an arithmetic sequence. We keep going to A sub n, some number that this could be 1,000, 100, a million, 15, whatever. So these are all the sequences, the terms of the sequence. So A1 is going to be what it is. A2 will be A1 plus D, where D is the common difference. Common difference, all right? So A2 is A1 plus D. A3 is A2 plus that same common difference. A4 will be A3 plus that same common difference. Got it? And so A sub n, this is a little tricky, would be A sub n minus 1 plus that same common difference. Whatever that number was before A sub n, I'm going to add the common difference to it. And that's what's basically happening here, what they're trying to show us. They're saying, hey, the first term is A sub 1, the second term is A sub 1 plus D. The next term is going to be whatever that term was, A sub 2 plus D. A sub 3, that last term, plus D. Got me? All right. So now that we have that, let's take a look and see if we can extend a sequence. Here in example 2, we're going to find the next 3 terms of an arithmetic sequence. Well, we're given that it's arithmetic so that we know that there's a common difference, and we can use that common difference to continue forward. So 74 to 67, that looks like a loss of, what would that be? A loss of 7? 67 to 60, yeah, that's a loss of 7. So technically I'm adding a negative 7. And so if I'm supposed to find the next 3 terms, then starting from 53, I'm just going to continue to add negative 7. So when I add a negative 7 to 53 over here, I'm going to get 46. When I add a negative 7 here, I'm going to get 39. If I add a negative 7 here, I get 32. Notice in each time I use the common difference of that, adding that negative 7 on or subtracting 7, same idea, to get to the next value. All right, let's look at another example. Okay, before we go to the next example, we've got this handy dandy arithmetic sequence equation that I want to talk about. So the nth term of an arithmetic sequence would be A sub n, and I alluded to that before. So if I want to know what A sub n is, I need to know what the first term is, and then I'm going to add to that a bunch of d's, a bunch of the common differences over and over again, but I'm going to add one less than the number that I'm looking for. So let's kind of think about it. I'm going to come up with a generic one: 2, 4, 6, 8, 10, 12, 14, 16, right? So you know, here are the terms of a sequence, and I've listed them down in terms of order. If I wanted to know, let's pretend I don't know what A sub 6 is, right? All I need to know is the first term plus 2. I need to know what the common difference is. That's 2 as well. So 2 plus, I'm looking for A sub 6. So I'm going to do 6 minus 1, which is 5, times the common difference, which is 2. So 2, sorry about that, that looks terrible. Let's try it again. 2 plus 5 times 2, which is 10, is equal to 12. Notice that gave me this value. So this handy dandy little formula, once I have parts of it that I need, I can find the other parts. So if I'm looking for A sub n, if I have A sub 1 and I have this d value and I know how many numbers I'm looking for, then I can determine what it is. Let's see if we can use this in the next example. So here we're looking to find a specific term. So here's an arithmetic sequence, and we want to find the 14th term. So our equation said a sub n is equal to a sub 1 plus n minus 1 times d, where d is the common difference. So if I'm looking for the 14th term, technically I can write that as a sub 14, right? A sub 14. So a sub 14 is going to be equal to the first term, which is 9, plus n minus 1. N is 14, and minus 1 would be 13 times the common difference. Well, the common difference can be determined. They told me it's an arithmetic sequence, so the common difference will be determined by looking to see what number I need to add each time. And I see it's 8, so I'm going to multiply that by 8. Does that make sense? Now, I know you're like, oh, I can just keep adding 8 14 times. This is actually easier, right? Not 14 times, but you know, the number of times I need to get up to the 14th number. So anyway, 13 times 8, let's see if I can do that. 4 down there, carry my 2, 8 times 1, 8, 9, 10. Get 104 plus 9 is equal to a sub 14. Therefore, ugly. Therefore, a sub 14 is equal to 104 plus 9, which is 113. So 113 is the 14th term in this arithmetic sequence. Okay, so we want to, in this example, we want to write an equation for a sequence given some information. So reading example 4, it says, consider this arithmetic sequence we have here. And I'm just looking at it and I can see that the d value from 12 to that is 11. You can see that that's 11 is my d value, is my common difference. Write an equation for the nth term of the sequence. No problem. We've got our generic equation which says a sub n is equal to a sub 1 plus n minus 1 times d. Well, since I'm dealing with this equation, I'm just going to put in what I know. A sub n is the nth term. A sub 1 is 12. Plus n minus 1, well, I don't know what the nth term is, so I'm going to leave that n minus 1, and the d value will be 11. So my equation, write an equation, I'm going to write this as a sub n is equal to 12 plus 11 times n minus 1, and I can move this around and simplify a little bit. A sub n is equal to, let's rock a little distributive property up in here, 12 plus 11, n minus 11, and I get a sub n is equal to 11n, wait for it, plus 1. And that is me using an equation to represent the nth term. So now we're going to find the 10th term of the sequence. Well, look, I already have this handy dandy equation that I simplified. Let's use it. So a sub 10 is equal to 11 times 10, right, plus 1. And when I do that, 11 times 10 plus 1 is going to give me 111. Yeah, okay, good. And I want you to see that if I had done the same thing, if I put the 10 in this equation, I would get exactly the same answer as that 111. Next, it says graph the first 5 terms of this sequence. Well, here are my sequence terms. I'm going to just have to get another one. I'm just going to add 11 to that, and I'm going to graph it. Let's make a table. So I'm going to graph the term numbers against the actual terms. So the term numbers in this case, let me make this a little larger. Since they said the first 5 terms, I'm going to use 1, 2, 3, 4, and 5 as my kind of x values, right? And then my y values will be the actual term values. I'm going to just cite up here 12, 23, 34. Let me write that down. 12, 23, 34. The next one was 45. And the next one, let me fix that, was 45. And the next one would be 56 if I just add an 11 onto it. And so if I'm to graph that, so now I'm going to actually just plot some points. So 1 is 12, and 12 is going to be slightly above that 10. And 2 is 23, which is going to give me a little ways above the 20, but not too much. And the 3 is 34, which is almost right in the middle. And the 4 is 45, which is definitely between 40 and 50. The 5 is at 56, which is slightly above the midway point between 50 and 60. And what I get is this beautiful line here. And so what we're seeing is that this arithmetic sequence also gives me a linear equation. So I'm hoping that was, if not satisfying, at least understandable. And let me know if there's anything I can do to clear it up. I look forward to seeing you soon. Please take care. I'll talk to you later.